Hello, everyone, and thank you for joining us for today's webinar, Vertical Foundations Supporting America's Infrastructure. Before we begin today's presentation, we wanted to cover a few housekeeping items to ensure you have a good experience. At the bottom of your screen are multiple application engagement tools you can use. All of the engagement tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. Helpful resources are bookmarked in the related content tool. Our webinar today is scheduled to last for 1 hour and will include a question and answer period. If you have a question, please type it in the question box at any time. Please complete our brief survey for PDH credit, and at the conclusion of today's webinar, we will provide more information on how to obtain the certificate. Today's webinar is hosted by Robert Chapman, Robert Moore, Jerry Skoda, and AJ Margettis. Robert Chapman is the Director of Product and Analytics and has been with Contech over 15 years. Bob Moore is the Regional Engineer in the Northwest region for Contech with over 33 years of experience in the construction industry. Jerry Skoda is the Director of Strategic Markets for Contech. He has 28 years of experience in the civil site development and drainage sectors with extensive involvement in wind turbine foundation design and construction. AJ Margettis is the Regional Sales Engineer covering the Chicago area. He has been with Contech for the past 25 years in several different capacities. Now I'll turn the presentation over to Robert Chapman to get us started.
At Contech, we have our sights set on becoming a leader in virtual collaboration. To achieve this goal, we have made significant investments in our technology, allowing for smooth and seamless communication between Contech, the engineers, the designers, contractors, government officials, and property owners. The platform you're reviewing today is a testament to those investments. During this webcast, you will be given opportunities to explore various topics in greater detail, view case studies and videos throughout the presentation, and ask questions to our presenters. All while our behind-the-scenes team pushes content relevant to what's being discussed on the screen. So sit back, relax, and get ready to learn about Contech's commitment to innovation, our interest in building out America's infrastructure, and our path to excellence in virtual collaboration. We're proud to work with owners, engineers, and contractors in the industry to deliver high-quality projects. At Contech, we understand the importance of collaboration and strive to be the partner of choice to owners. We work closely with our clients to provide education on solution development to meet even the most challenging project lead times wherever that project is located. Our expertise and knowledge of the industry, along with our proven product, make us reliable partners for engineers. We understand the complexities of environmental regulations and provide strong engineering support to enhance design efficiency throughout the process. Finally, Contech works with contractors to ensure projects stay on schedule and meet budgets. Our logistics and installation support satisfy foundation requirements and gives peace of mind for structural integrity for all of our projects. Steel is a material that has been playing a crucial role in the modern world for over 150 years. Not only is steel strong and durable, but it also is a sustainable material that is changing the way we live. The products that we'll be discussing in today's webinar are made with 100% American-made steel. This means not only are we supporting our local communities and businesses with infrastructure products, we're also reducing our carbon footprint. Steel production in the United States is highly regulated. It uses cutting-edge technology to minimize its impact on the environment. In addition to its production sustainability, steel is also a recyclable material. This means that steel products can be reused and recycled, reducing the need for new steel production in the United States and the associated environmental impact. The recycling of steel conserves natural resources, reduces energy consumption, making it an eco-friendly choice for construction and manufacturing. Welcome to our webcast on vertical foundations in infrastructure. With decades of experience in designing and delivering innovative site solutions for a wide range of infrastructure projects, we've established ourselves as a leading provider of civil product solutions. Our expertise spans across wind turbine foundations, utility pole replacements, bridge piers, crane enclosures, transmission lines, petroleum cellars, and general concrete forms. We've built a long history of success in this area. Join us today as the team deep dives in the world of vertical foundations as we share our knowledge and insights in this crucial aspect of our infrastructure. On November 15, 2021, the Infrastructure Investment and Jobs Act, IIJA, was enacted, allotting $550 billion in funding for infrastructure improvements over the next 5 years. However, determining how these IIJA funds will be dispersed among states and local governments can be complex. To assist DOTs, partners, engineers, and owners, Contech has compiled essential information about these programs in one convenient location. With a wealth of expertise in infrastructure site solutions, including bridges, culverts, drainage, stormwater detention and treatment, Contech is a trusted partner for DOTs, engineering firms, and contractors searching for knowledge and expertise in the infrastructure world. Recently, Contech has been instrumental in the success of infrastructure projects throughout the United States, including EV battery disposal facilities, EV production facilities, runway safety upgrades, and stormwater treatment and storage for schools and libraries throughout the United States. With a focus on providing top quality engineering service and products, Contech has demonstrated its ability to deliver results across the spectrum of infrastructure initiatives in the United States.
Well, thank you, Rob. Now we're going to transition to a poll question. We would like to know, have you ever applied for a grant funded by the Infrastructure Investment and Jobs Act? Please select yes or no. To submit your poll answer, please click the answer on your computer screen and then click the submit button. I'll give you some time now to mark your answers. And thank you all for joining us this morning. We'll give you some more time. The answers are rolling in. Just a reminder, if you have a question, type it in the question box and we'll answer them at the end of the presentation. I'll give you a few more moments and thank you for participating. Okay, great. Looks like most of you have answered, so thank you. And here are the results. Looks like 95.7% say no. So with that, we're going to turn it over to Bob Moore, and he's going to talk about the history of vertical applications.
Hello, everyone. My name is Bob Moore. And for these first few slides today, I want to talk to you about the history of the steel caisson, as well as giving you some various applications that have been constructed with vertical corrugated steel pipe. So the first city to use caissons is the city of Chicago. When a lot of the buildings were starting to be built downtown in the mid-1800s, they were sinking. And so Chicago was one of the first cities to experiment and use deep pile foundations to support their buildings. And this was in between, came between the mid-1800s to the 20th century. So that's for the deep piles, and they're very good at supporting the buildings. But the negative part of the deep piles were they would affect the nearby building, particularly the older buildings, and they would do damage to them. So back in 1894, the Herald Building was one of the newer buildings in Chicago. They had the city of Chicago put an injunction on how close piles could be driven next to their building. So the civil engineer on the project, his name was General William Soy Smith, had to come up with a way to support this building next to the Herald Building. So this new building was the Stock Exchange Building in Chicago. And if you can see this picture in the lower right-hand corner, all those points are all deep-driven piles. Next to the Herald Building, on the north part of that drawing, they were what we call caissons today. The general called them shafts, but all the construction workers referred to them as caissons. And we don't know, but we believe the reason they referred to them as caissons is because he was a general in the Civil War, And that's a traditional definition of a caisson, was a chest that you would store ammunition in. So I don't know if they were doing it to mock the general or doing it to compliment him, but those first caissons were about 7 foot in diameter, 6 and 7 foot in diameter, and they were hand dug. And he designed them with steel rings going around, just like you would a bourbon barrel, with wood lagging. The same type of construction is still used today. So the photo you see in the upper right-hand corner is what we'd call a ribbon lagging shaft. Again, those are still built today, but first used in 1984, and it was out of necessity that the first caissons were designed and constructed. And A.J. Margettis later today, or later in this presentation, is going to talk to you a little bit more about the Chicago caisson. All right, corrugated steel pipe. A lot of folks know it as cross culvert pipe. In 1896, it was invented for hydraulic applications. Since that time, many uses have been designed for vertical applications. So what you see in the upper right-hand corner is a photo of a 70-foot long piece of corrugated steel pipe with no joints. That's one of the big advantages of corrugated steel pipe. We can make it in most any length that you can ship. So if you have a project that requires 13-foot caissons or 17-foot caissons, those can be made. So they can be made to any length. So the photo nearest on the near left is really of a bridge project. This is a Kentucky transportation cabinet project. They're using 30-inch corrugated steel caissons to enclose H-piles. The H-piles are going to support the bridge. The purpose of the corrugated steel pipe is to prevent any drag down forces of the new constructed embankment acting on those piles. And so that is its purpose. So it's just taking that load relief off those piles. So it's just supporting the bridge itself. It's just a more efficient way to design that bridge. The photo on the far right is of a crane enclosure. This is a 12-foot diameter, 40-foot high, what we call crane enclosure. And the purpose of a crane enclosure, you see these a lot in urban areas where they're building a new building or a parking garage, and they're building up an embankment. So that area is going to be all soil embankment right adjacent to the enclosure. And that's a permanent stay-in-place form. So as they bring up that fill 40 feet, then eventually they're going to disassemble the crane. And when they do, then they're going to fill that pipe up with soil. And so the picture on the bottom there is of a shaft. So that's 11-foot diameter corrugated steel pipe shaft. And you'll use a shaft in areas where you cannot excavate a large deep hole. Usually those are in urban areas, and the tunnelers they're Warren jacking pipe from one area to another. That's what you're going to need a shaft for. Shafts are designed a little bit differently than caissons in that they're designed more conservatively. And the reason is that we have construction workers in there, and the whole purpose of the shaft is to support the construction workers while they're actually in the pipe itself. And design of these products, usually we use for both caissons and shafts, we use what we call American Iron and Steel Institute modified design for those. And that's something that we can help engineers and contractors with. Why corrugated steel pipe? Okay, there's two ways to increase the strength of a conduit, a steel conduit. And that would be, number one, by increasing the steel thickness, or two, by corrugating it. And it's much more efficient from a cost perspective to corrugate something. Just like when you do an I-beam for a bridge. The deeper the corrugation, the stiffer, the stronger the pipe, the deeper the I-beam, the bigger the span for that bridge. So we make them in various corrugation depths. 1.5 and 1 inch are typically for corrugated steel pipe. And what you see in that picture on the lower right is an 11-foot diameter caisson with a 1 inch deep corrugation. We also make deeper corrugations for various plate products, so we can increase the size of that shaft or caisson. And here's some really good examples of that. The photo on the lower left is of a telescoping shaft that's over 60 foot deep. That's made of multiplate, which is bolted in the field. So this is about a 16-foot diameter. You know, you usually, depending on where you are in the country, on the cusp of where you can ship a single piece of corrugated metal pipe or whether it needs to be built in the field. The next photo is of a 26-foot diameter, 50-foot deep shaft. This was made out of tunnel liner plate, so it's really a hand-dug shaft, very similar to the way that those first caissons or shafts were constructed in Chicago back in 1894. But instead of ribbon lagging, they're done with steel plate. The next photo you see is of a crane enclosure. So we're looking at street level of a busy city in an urban area where they had a couple crane enclosures they needed. This particular building was a multi-story apartment building being put in. And of course, they're going to take this out when they disassemble the crane, and they're going to fill that hollow space up with soil. The next photo and last on the far right is of a 72-inch diameter caisson that was drilled and dropped in place and used in utility transmission line construction. So again, we have various corrugation depths based upon the diameter of the shaft or the caisson needed. So the best thing about working in the construction industry for all of us on this call is to be a part of a really big project. And we were very fortunate to be a part of the SoFi Stadium project in Los Angeles, California. So for those of you who don't know, the Los Angeles Rams and Los Angeles Charger American football teams play at SoFi Stadium. Last year, also the Super Bowl was played there. Contech was able to supply over 25,000 lineal feet of various pipe diameters of isolation caissons, or some people call them hollow caissons. We showed you a picture earlier of a construction project on a bridge where the caisson encased over the pier or the H pile, and sand was filled in there. In this particular case, there was no filling. They were hollow. So these concrete columns supporting the stadium had these larger diameter corrugated steel pipe forms surround them. And the whole purpose of that, not filling those, was to minimize any damage to the foundation if there were to be an earthquake. So it was an interesting application on this particular project. But as you can see, it was really a massive project. It was a big project in the city of Los Angeles. And it was really great to be a part of it, and knowing that, you know, simple technology like caissons is helping protect all the fans in the stadium and protect that building. So next up, we're going to have Jerry Skoda get a little bit of deep dive into wind foundations.
Oops. Thank you, Bob. A little bit of story about myself. I've been with Contech about 28 years. I've been involved in the wind industry for about 23. And through those 23 years, I've supplied products into about 6,000 pier and anchor foundations located across the United States, China, Canada, and Jamaica. Today, the agenda, we're going to do a review of the wind industry that we cover from a Contech product offering. I'm going to do a little historic foundation perspective, and we're going to discuss the pier and anchor foundations. Traditionally, they were known as the P&H Pier or Patrick and Henderson, but in 2019, Terracon purchased the patents, and the name moving forward will be called GripTerra. So let's look at a little bit deeper of the Contech product offering, which fall into two major buckets for us. The first bucket we're going to talk about is our bridge bucket, which basically falls into three categories: our plate structures, our precast concrete, and our truss and beam. A little bit of information about our plate structures. The spans range between 5 to 52 foot. These buried structures can be designed to handle live loads provided from aircraft loading up to the largest haul trucks to date. Some of the advantages of plate: they come in lots of shapes and sizes. They can come with open bottom or full invert. The length of the structure can easily accommodate the site requirements, which are typically 40 foot wide on most of the wind farm jobs. And they allow construction in areas, in remote areas, and they can use smaller equipment to install, so very advantageous to wind farms. Our second are our precast concrete structures. These structures can range from 12 up to 102 feet. They can meet the same design criteria I just mentioned. They can come in with open bottom, full invert. And typically on wind farm jobs, they're provided with open bottoms, so not to disturb the blue line streams. If you look in the top right of the picture, that is a conspan structure with a precast head wall and wing wall. So they work very well in wind applications. Our third bucket would be our beam and truss structures. Our vehicular spans range between 20 and 100 feet. The picture to the right reflects a good example of an entrance to the Butler Ridge wind farm up in Wisconsin. Being the most cost-effective alternative to large spans, this entrance structure was chosen due to the cost and speed of construction while being able to handle the equipment and component deliveries. As you know, each component must be delivered, so it had to cross the structure, so it was designed to handle those loads. Moving on to our next big bucket would be our drainage portions. A typical wind farm drainage size pipe fall in the 15 to 60 inch diameter, with corrugated metal pipe and high density polyethylene or HDPE making up the bulk of the products used. Our Contech product offerings come in a few different types of materials. Our first is a corrugated metal pipe. We do have steel reinforced HDPE, and we have a PVC offering. Most of these material callouts usually follow the local DOT specification, but our local sales engineers can also help you with coding and gauges required. But let's look at the corrugated steel pipe. These sizes range from 6 inch to 198 inch. 198 inch. We have 50 plants nationwide, and these typical diameter ranges are 12 to 144 inch coming out of the plant. So we can supply pipe easily in any location across the United States. We do have a mobile mill, which is pictured to the right. This vehicle allows us to produce between 12 and 198 inch pipe. We can do lengths up to 45 feet in the larger diameters, and this eliminates costly over-the-road hauling fees and restrictions. Let's look at a couple highlights of the site requirement for the mobile mill. Projects that typically have $35,000 or more in freight, we start looking at, is it the mobile mill the more cost-effective option? Once we decide that it is an option, we need on site a 200 foot by 200 foot stable, level, gravel-based site, which has the capacity of supporting a 60,000 pound vehicle. We need an adjacent storage area suitable to handle the pipe that is produced. And then a contractor would take it from that storage area to each location. In Contech, we provide all the labor, equipment, material, and fuel to run that site. So let's give a little historic perspective on the foundations. So since 1994, there's been about 7,000 of these foundations installed, which have generated greater than 15 gigawatts of renewable energy. And a little quick fun note about it is 1 gigawatt of energy produces enough power to support 725,000 homes. These foundations have supported the largest land-based wind generating turbines. We've got a couple projects up in the 4.5 megawatt machines. We're currently looking at 6 megawatt machines, which would be the actually largest, so it's under design currently. Another interesting fact, we had a project down in Jamaica, had just finished construction, and Hurricane Michelle in 2001 came through. This Category 5 hurricane hit the 41 foundations that were just newly completed, and we had 0 catastrophic loss of turbine and foundation. So it just shows the advantages of what deep foundations can provide. I'm going to show a video shortly, which is going to go through the construction of a Pier foundation. As I said, formerly known as a P&H Pier, but we'll be calling them GripTerra Piers. And that's due to the Terracon Consultants purchase in 2019. But a few general points. Pier foundations are soil dictated. We have to have favorable soil conditions of either soft or hard rock, dry or wet, silty or clay sands. Mostly the soils must stand vertically with minimal slough. We excavate an 18-foot diameter hole, typically to the depth of 28 to 34 feet. And also, if you have limited groundwater near the surface, this is also favorable. That's all done through a geotechnical report, and each foundation can identify the proper sites. These holes are typically excavated or drilled, depending on the soil conditions. They can be built in the rock applications as discussed, but can be accomplished. We must blast the rock out and allow the construction to move forward. These rock applications provide the highest factors of safety. A typical wind foundation is designed to a factor safety of 2. Once these deep foundations are installed on top of or within rock, the factors of safety go from 4 to 10, which is a great advantage. So now we're going to review the installation video and hit a few advantages afterwards. Oops, let me push it to you guys. There we go. So when we're looking at this foundation, like I said, the hole is either excavated or drilled depending on the soils. It's an 18-foot diameter hole. Hole. The outer can, which is typically 16-foot or 14-foot diameter, 28 to 34 foot, is lowered into that hole. Once it's holed, the annular space is grouted to lock it in. A superstructure is installed over top, which allows the full-length anchor bolts to be installed. The deep foundations with these full-length anchor bolts allow it to be post-tension. This is critical to extending the fatigue life of these foundations. Once that template is placed, the bottom template is installed and is lowered back down into the hole. An inner can, inner corrugated metal can, which is typically a diameter of 10 to 12 foot, is lowered into this superstructure. A concrete grout plug is poured. One of the advantages is the excavated soil is used to refill the inner can, which reduces this overburden handling. Once that's placed, structural concrete is poured between the inner and outer can, which is a 6,000 PSI concrete. And currently we've been installing a tension cap on top of it. So it's a multi-plate structure with radial bolts that are placed, and then it's poured with 6,000 PSI concrete. These radial bolts are tensioned. The structure is filled with concrete and then backfilled, and the structure is ready to receive the tower. Typically, you have your initial tensioning of the full-length anchor bolts. We do a check at 6 months, and then at the end of the year, due to bolt relaxation, you would do your final tensioning, and then that tower is ready to be received. And then periodically, there's a maintenance program which allows that the owners would go back through and post tensions, typically every 2 or 3 years. But let's look at some of the advantages of this Pier foundation. As the tower heights increase and the megawatt machines get larger, the gravity type spreads are approaching the limitations from a performance and construction cost. Deep foundations are positioned to capitalize on the advantages they possess to address the massive overturn and lock-off loads that are required by these turbines. Deep foundations are specially used here in Southern California, and they excel in seismic and flood water areas, particularly near Palm Springs. If you've ever driven out to Palm Springs, there's about a couple thousand of these currently in operation. With the extended fatigue life and other key characteristics due to post-tensioning, we have the ability to recertify the foundation. And what's happening today is projects are being able to go back and be repowered, meaning there are new towers and turbines being installed on the existing foundation. So that saves the owner moving forward multiple costs of the foundations. Post-tension foundations on turbines 2.5 megawatts and larger are the most cost-effective for construction when the soils are conducive. From a materials standpoint, and a installed cost, we're seeing savings of about 40% versus the traditional gravity spread footers. Next, we're going to move on to the GripTerra anchor foundations. Key factors of the anchor foundation is the flexibility to use in the largest range of soil and rock conditions out there. Again, they can hit the soft and hard rocks, the dry and wet silty clays. We're currently currently in the process of starting a project down in Mississippi. It's going to be constructed in the bogs of Mississippi, and the anchor foundation was the only option without large soil mitigation as an alternate. So we'll be starting construction on that project in the next month and a half. On these anchor foundations, our multi-plate products are used. And these typical rings, which are inner and outer can, are 30 to 36 feet, and the inner can is about 10 to 14 feet, depending on the turbines and the flange base. So we're going to watch this video real quick, and I'll walk you through some of the advantages. So the advantages of the anchor foundations, they can actually sit on surface grade or be buried. Actually, in the Mississippi job, the ring is going to sit at grade so that we don't do any soil disturbance. Typically, what they'll do is they'll install the anchor systems. These anchor systems can be hollow stem, auger cast piles, helical, or driven piles. Once they're in place, the electrical sweep and the mud mats are installed. The outer can or multi-plate structure is installed, and the inner can is assembled. Radial bolts in lower and upper location are installed, and then that full structure is poured with concrete. Once it's filled with concrete, which is typically about 6,000 psi, all those radial anchor bolts are tensioned along with the vertical anchors. One of the big advantages about this foundation is that the foundation is completely tested prior to the tower being installed, and so there's the advantage of that. Again, with this anchor type foundation, any turbine size can be accommodated for these anchors. Let's say there's a project that is actually installed and some of the soil conditions become different. The advantage of this foundation is that if you needed to add an anchor or two afterwards to accommodate the soil constraints, that can be easily modified. They have the widest range of soil conditions that they can be built on than any type of foundation in the market. These foundations can be recertified and repowered. We're actually repowering with NextEra about 3 projects currently, and a couple up in the Goldendale area up in Washington. These products have the lowest site disturbance of any foundation out there. And just like the P&H Pier, these anchor foundations have a typical savings of anywhere between 25 and 40% versus the gravity spread footings when you get into these soil conditions that are a little bit more aggressive. So just in the conclusion, we provide product into these foundations. Terracon consultants handle the design of the foundations, and we are a supplier in it. But I've been involved with site walks. I've been involved in the early designs and working with the contractor supplying. So that concludes the wind farm. And I believe Jill will have a poll question to follow.
That's right, Jerry. It's time for our next poll question. Our question is, what products typically come to mind when considering foundation solutions? Is it concrete, corrugated steel pipe, or rolled and welded steel casings? I'll give you some time now to mark your answers. And to submit your poll answer, please click the answer on your computer screen and then click the submit button. I'll give you some more time to mark your answers. And just a reminder, if you have a question, please type it in the question box and I will ask you at the end of the presentation. Looks like here's our results. It looks like 89% say concrete, 7% say corrugated steel pipe, and 3% say rolled and welded steel casings. So now I'm going to turn it over to AJ Margettis to talk about foundation solutions for utility poles, pier foundations, and more.
Thank you, Jill. Hello, everyone. I'm AJ Margettis, and I'm glad to be joining you today from Chicago, Illinois. And I think that's somewhat fitting, as we've learned that Chicago has some historical significance when it comes to a particular type of vertical foundation. It was fascinating to listen to Jerry talk about the windmill foundations, and I've kind of been involved or understood those designs from back 20 years ago, and it's very interesting to see how all of that has evolved. I'm going to round out today's discussion by talking about some more common applications that we see corrugated steel pipe used in from a vertical foundation perspective. A lot of these have been touched on, and I'm just going to go into a little bit more detail about how corrugated steel pipe is used here and the advantages that we see along with that. The first market that I'd like to talk about, or application that I'd like to talk about, is for the use of corrugated steel pipe as a permanent stay-in-place form when constructing electric transmission towers. Every year, Contech is involved in the supply of corrugated steel pipe for the construction of many thousands of new towers, such as these monopole towers that you see on the right. And we also get involved in the construction or rehabilitation of building towers that have been damaged by things like hurricanes, which we've seen unfortunately too often in the Southeast. The construction sequence of these is relatively straightforward. A drilling contractor will understand the diameters that they will need to drill throughout the transmission line segment that they're doing, and they will pre-order corrugated steel pipe to those diameters and specific lengths. If you'll remember, Bob Moore talked about how we can make really almost any length pipe, and that is true for any diameter as well. So the contractor will come in and drill their hole to the appropriate diameter, and then they will set the corrugated steel pipe casing so that it stabilizes the hole, especially in the upper reaches where the soil can be known to slough quite a bit, and it will stabilize the hole so that they can perform their other work, such as setting of rebar, the placement of any anchor assemblies, and then the pouring of concrete, so that that is ready for a tower contractor to come in behind them and eventually erect those towers. I mentioned we get involved in lots of these projects every year, and I just like to highlight one of them that I was involved in back in 2016. This was done for the owner, was the Northern Indiana Public Service Company. And they were upgrading their Reynolds, Indiana to Topeka, Indiana transmission line. They hired a drilling contractor out of Dundee, Illinois, CJ Drilling, that we've worked with quite a bit, who in turn hired Contech to supply over 700,000 pounds of 12-gauge corrugated steel pipe, ranging in diameters from 7.5 feet, 90 inches, to up over 10 feet in diameter, 120 inches. One of the unique components about this project was the manufacturing location. It was not at one of our plants. It was on site, as Jerry had alluded to. We have the capability to do this if the site sets up for it. We have a dedicated crew and equipment that are able to come in and manufacture this all on site, with the advantages of saving the cost of hundreds of truckloads, many hundreds of truckloads. The contractor didn't have to worry about the logistics associated with that. They did not have to provide labor and equipment to offload all of those truckloads as well. We have forklifts on site that were able to stage all of the corrugated steel pipe for the contractor, and it made their life very easy. So this was a win-win-win situation for Contech, for CJ Drilling, and for NIPSCO. The next application that I'd like to dive into in a little bit more detail is corrugated steel pipe used in the construction of new bridges. There are a couple of different applications here. The first one that you see and that Bob had talked about just a little bit is CSP used for H-pile encasements. Now, generally, these are going to be some of the smaller diameter ranges, such as 24-inch and 30-inch in diameter. And one of the key aspects or applications that we see this used in is this detail on the right side of your screen here. Along with the new construction of bridges, a lot of times, especially in urban environments, we're seeing the need to have mechanically stabilized earth retaining walls constructed as well, or an embankment constructed. Behind those MSE walls is a structural backfill zone. And ultimately, that structural backfill zone is going to surcharge the in situ soils below there and create settlement over time. If the corrugated steel pipe casing that is also then filled in with sand was not there, all of those drag down forces would be negatively acting on the H-pile itself. So the CSP casing acts as a protection, and it takes up those drag down forces. And because of the sand or bentonite that is placed in between the CMP and the H-pile, they're actually allowed to move independently of each other. And so that's a very common type of design that we see a lot used for the Illinois Tollway around the Chicago area. And you can see a picture of a wall here on the left during construction where those CMP pile sleeves are being placed around it. Another application that we see corrugated steel pipe used in is in much larger types of drilled shafts. And we see a lot of this work in the Arizona market. And in fact, the detail that I'm showing you here on your screen is from an Arizona DOT project. We've also seen it done in California quite a bit, and I'm sure that there's other states out there that can use this type of technology. But looking at the far left of your screen here in profile, we see a 10-foot diameter drilled shaft. And you'll notice that up at the top, that gets wider. There's a construction joint that takes place about 12 feet below grade or so. And that construction joint marks a transition from the drilling contractor to the general contractor who's going to be taking it from there and building the rest of the bridge. In order to be able to provide a safe working environment, a corrugated steel pipe, typically 4 feet larger in diameter. So in this case, a 14-foot diameter corrugated steel pipe is dropped in and back grouted so that it stabilizes the upper reaches of that soil column. That's going to provide a safe working environment for the general contractor to come in and perform their work, such as cleaning the construction joint, setting a rebar cage, and then pouring concrete. In the past, what needed to be done before folks started using corrugated steel pipe is they would use temporary welded steel casings. And you can imagine that that's going to be extremely heavy to try to extract. So they would need to use very large cranes to extract that. It was somewhat of a safety issue. But also during the extraction of a temporary welded steel casing before the concrete sets up, that would have a tendency to shift the rebar cage out of alignment. And that would create all sorts of other problems in trying to get that back into alignment. So now that most contractors have shifted over and changed to using corrugated steel pipe, they don't need nearly as large of cranes, so it's more economical. It's safer, and they don't have the construction defect potential of shifting that rebar cage. So the next slide I'd like to show is I just have to do this as a corrugated steel pipe nerd, if you will, but show you our largest corrugated steel pipe ever manufactured at a plant and shipped to a job site. This was done for an Arizona DOT Highway 303 project. Our customer was Keller North America, and this was back in 2016. This will likely never be eclipsed because several factors had to line up for us to be able to do this. Number one, our Arizona facility is an outdoor facility, unlike many of our plants. So they didn't have a building constraint, and they were able to manufacture this 15.5-foot diameter CMP. Number two is it was extremely close to the job site. The entire highway had to be shut down. No cars allowed, no public traffic allowed while this traversed from our plant to the project. And very luckily, we did not need to cross underneath any bridges, so there weren't any clearance issues. So for that reason, this will probably stand as the largest corrugated steel pipe ever made at a plant and shipped to a job site. For the next few minutes, I'd like to touch in a little bit more detail and talk about this specific drilled belled shaft, otherwise known as the Chicago caisson, that Bob Moore had touched on earlier. Chicago is uniquely underlain by very poor soils. At the end of the Ice Age, when the glaciers retreated, they deposited, if you look over on the left side of the screen, it's represented by this thick gray band layer. They deposited a 30 to 50 foot thick fill of what's known as Chicago blue clay. Chicago blue clay is highly compressible with a high liquid content. And as Bob had mentioned, many of the initial buildings that were being built were failing. So there was an enormous, essentially trial, error, and correction period in the late 1800s of building foundation and foundation engineering that went on. And ultimately, what was determined is that we need to get down below this Chicago blue layer and down into this hard pan. The green area that you see on the left is a hard pan, which is also clay and is very, very stiff. This hard pan today allows for the bearing of buildings in the neighborhood of 35 up to 40 feet or 40 stories tall, if you will. If for much taller skyscrapers that usually jump up to 70 stories and larger, those are going to need to be founded in bedrock below those last two layers that you see in the left. So now I'll just talk a little bit about the sequence and how corrugated steel pipe is utilized in this type of application. So typically a contractor is going to sink a little bit larger diameter welded steel pipe, and they will sink that so that it is in that blue clay layer in order to lock it in and have no water coming in. They will then drill their shaft, and then they will then bell the bottom of the shaft. And once that is done and the bearing capacity has been confirmed, they will drop in a corrugated steel permanent liner that goes 2 to 3 feet below the temporary steel casing. It's there to stay and allows them to be able to set any rebar, pour any concrete, and at the same time be able to pull their temporary casing out of the ground. So corrugated steel is basically making the construction of these drilled belled shafts as economical as it can possibly be. And here's an example of kind of how that looks, or some of the activity and equipment that you see on the far left. You can see the drill rig that has a beller on it, so it's either being excavated up or getting ready to be lowered down to bell the bottom of the hole. In the middle, you see an example of the beller piece of equipment with its wings out. And then over on the left, you can see the permanent CMP casing that's being dropped inside of the temporary casing. That will be lowered 2 to 3 feet below it. And then ultimately they can perform the rest of their work, or set rebar, pour concrete, and eventually pull their temporary casing. So what you've seen here throughout all of this, you've seen a mix of, there's a lot of contractors, our drilling contractors in particular, that have noticed and figured out via means and methods how corrugated steel pipe can be advantageous to their work. But you've also seen in some of the instances around H-piles and some of the Arizona DOT work that engineers are also specifying the use of corrugated steel pipe. for specific types of vertical applications. And there's many that we haven't talked about here today that you don't get to within an hour time frame. So we hope that you've seen lots of different applications, and this has sparked your interest in the capability of utilizing corrugated steel pipe. And we want to talk to you about just show you some of the resources that you have available. Most importantly, at the bottom of your screen, there is an infrastructure project inquiry form for anybody who's working on any infrastructure projects today. You can fill that out and get very, very fast responses. So please feel free to do that. I would also urge you to go to our website and look at all of the content that's available there. There are a lot of design your own tools where you can design your own detention system or bridge or reline project. We have product design worksheets that you can fill out. There are articles that you can read and answer questions to get PDH credits, and plenty of other items. Most importantly, know who your local Contech resource is. They can be your best friend in terms of providing you the information that you need. So know who your local sales engineer and stormwater consultant or bridge consultant are and how to get in touch with them. We greatly appreciate your the opportunity to present here today and for you joining us. And now we'd like to open it up to questions.
That's right, AJ. If you have a question, please type it in the question box and I'll ask them at this time. Our first question is, what is the advantage of manufacturing the ducts on site where they are bolted?
So if you're talking about the mobile mill, typically you'd have to have a site, like we said, for the manufacturing would be a 200 by 200 foot area where the machine is set up. You'd have to have adjacent storage. So depending on the size of your project, we can tell you if you need a half acre up to 5 acres. Some of the restrictions that we look at is make sure there's no noise restriction. The chop saw on our mobile mill sends out some high decibels, so we got to make sure there's no noise restrictions. We have to know if it's a union job, prevailing wage, anything particular. And the biggest thing is sometimes we hit work time limits. Can we work nights? Can we work weekends? Because typically when we come on with the mobile mill, we want to work 10 to 12 hour days to get in, get out as much as possible. The cost of the machines out there and putting up the men. So we want to schedule pretty tightly with your contractors. Hopefully that answers your question.
Thank you, Jerry. And the next question is, how do you make the steel duct in one piece without bolts?
Say that again.
How do you make the steel duct in one piece without bolts?
So corrugated metal takes flat sheets and it forms a helical lock. So the pipe forms into the diameter using lock seam, and that is the length. Once we get past a certain diameter, that's when we would move to the multi-plate, and then the multi-plate is a bolt together option.
Thank you, Jerry. The next question is, what is the maximum depth and the maximum soil pressure that can support?
Bob, would you like to handle that one?
Repeat that, Jill.
What is the maximum depth and the maximum soil pressure can support?
Well, the maximum depth is really dependent upon the diameter of the shaft or the caisson you want. We've been involved in projects as much as 100 foot deep. Anything over 50, we're going to take a look at, right? Depending on the diameter, and those pressures are going to be dependent the soil pressure and probably if it's a high groundwater table situation. So that pressure, I'd probably say the limits depending on the diameter, probably 100 foot, but those would be that'd be a really deep shaft, right? But we've done those that big before, so, and the corresponding pressures with that in a high water table situation.
Thank you, Rob. Our next question is, when constructing transmission tower foundations, why don't drilling contractors use temporary welded steel forms that can be reused versus permanent CMP?
I'll go ahead and take that one. That's a good question. Sometimes temporary liners or temporary casings are utilized, but if you'll remember back to when I was talking about the Arizona DOT project with the large diameter drilled shafts, the problem that had is when that temporary casing is removed, it can have a tendency to shift the rebar that's inside. In regards to the transmission market, the anchor assemblies or anchor bolt locations have to be pretty precise so that when the driller is done, the tower contractor can come in and easily erect the towers with the anchor assemblies in the right place. So for that same reason, a temporary form that's pulled before the concrete sets up is liable to shift the location of those anchor bolt assemblies. So for that reason, contractors prefer typically to utilize the permanent stay-in-place form of corrugated steel pipe.
Thank you, AJ. Our next question is, can Contech provide recommendations for the gauge of CMP liners in vertical applications?
The answer is yes. We can be an assistance to you on that. Just contact your local Contech sales engineer.
Thank you, Rob. Our next question is, can Contech provide recommendations for grout lift heights in the annular space between the drilled shaft and the CMP?
Yes, again, you can contact your local Contech sales engineer. Many contractors have done it and will design their own, but we can give them, certainly we have design guidelines for that as well.
Thank you, Bob. Our next question is, who provides the design of these deep wind foundations?
Yeah, I'll take that. Terracon Consultants has the patent on the P&H Pier and the anchor foundation. So they typically do their geotechnical survey and testing, and then they would be able to provide you the design of the foundations.
Thank you, Jerry. And we have time for one final question. What is required on site for using the mobile production vehicle? And is there anything special for the contractor or owner?
I just said a little bit earlier, but I hit it again. You need a area for the machine to set up which is level and gravel based and can support a 60,000 pound vehicle. You need an adjacent storage area that can store the pipe that is manufactured. We bring in the equipment, we bring in our fuel, we bring in the manpower and the coil and materials. So basically the contractor, we have to go through any restrictions from a work hour restrictions or noise restrictions, make sure we meet those. But basically having a site that can accept the machine and accept the produced pipe is kind of the first step in limiting factors.
Well, thank you, Jerry, Bob, Rob, and AJ. Before we end this presentation, I just wanted to point out at the bottom of the screen, there's an icon to register for our upcoming webinar on March 30th at 11 a.m. It's Maximizing Your Project Dollars with Contech Buried Bridges, Efficient, Economic, and Extraordinary Uses of Plate and Precast Structures. So thank you for participating in today's webinar. If your question was not answered, a Contech representative will reach out to you with a response. A survey will appear once we conclude the webinar, or it's also located on the screen right now. Please complete the short survey to receive your PDH credit. A follow-up email will be sent by the end of the day that will include a link with instructions on how to download your PDH certificate. That concludes today's webinar. Thank you again for joining us and have a great day.
Thank you.
Thanks.